Good day, future electrical engineers. So this is me again, Engineer Jonathan Monterola. So we are done with discussing the first type of compound wand DC generator, which is the short shunt. So this time we'll discuss the second type of compound generator, which is the long shunt. Okay. A long shunt compound generator is a type of generator where the shunt field is connected in parallel with the both series field and the armature winding. So as you can see here in the schematic diagram, so the series field winding is connected in series with the armature winding here, and then that combination is connected in parallel with the shunt field winding here, and then the load is connected in parallel with the shunt field. Okay, and this is the armature. Okay, the shunt field current is equal to, so this one ISH, since by inspection, so there's no other components here, no, so meaning, so VL is equal to BSH. So that is why to find ISH, the current across the current of the shunt field is equal to the voltage terminal divided by the RSH. Okay, so VSH, since VSH is equal to VL. Next is armature current IA. So see delay the pita, no? This is IA. So to solve for IA by inspection also, so since the series field winding is connected in the armature winding, so they must have the same current all. Okay, so IEC IA is equal to IL. So by referring this at this node, no, so if we are going to assign this node A, so current entering is equal to current leaving. So current entering is IA, and then current leaving is IHH and IL. So that is why IA is equal to IL plus the ISH, no, the current across the shunt field. Voltage across the load is equal to, okay, so voltage across the load, this one. Okay, so V is equal to the generated EMF, because as I've said, VSH is equal to VL. Okay, so generated EMF here minus the voltage drop across the armature winding minus the voltage drop across the series field winding. Since they have the same current, no, the same current, since they are connected in series, so simplifying, so IEC is equal to IA, so AG minus IA times the quantity of RA plus REC here. The power generated is same, no? So whatever the generated EMF times the IA, so that is the generated power. Then power delivered to the load, the same. So VL IL, no? It might be if the given is ang current IL and R, so you can have I squared R. So let's have an example. The long shunt compound generator is rated 22 kilowatt at 220 volts. It has armature series field and shunt field resistance of 0.01, 0.03, and 110 ohms respectively. The series field is shunted with a diverter resistance, which is 0.02 ohms, and the voltage drop of 1.5 per brush. Okay, so 1.5 per brush. So find the generated EMF. So by evaluating, so we can have a schematic diagram equivalent. So we have VL is equal to 220. Okay, so we have RA 0.01, RSH is equal to 110, REC is equal to 0.03. And then the REC is the connected, no? We have diverter resistance connected in parallel with the REC 0.02. Okay, to solve that one, no, find the generated EMF. So here, no, what is the generated EMF? So first is get the load current, no? So IL. So to find load current, we have the power delivered to the load is equal to 22 kilowatt. So 22 kilowatt divided by 220. So 220 the VL. So we have IL which is equal to 100 amps. Okay, so next to find out is what is the IHH, here. Since VL is equal to VHH, so, and then we have IHH given, so we can have this one. So 220 divided by 110, which is equal to 2 amperes. So next, since we have IL and IHH, we can have the value of IA. IA is equal to the sum of IL and ISH. So 102 plus 100 plus 2, 102 amperes. So that is your armature current. Next is, since we cannot directly solve this one since napatay combination, parallel combination. So we'll simplify first the schematic diagram. Okay? So to find the combination of REC and the diverter resistance, we can have this one, product over the sum. So 0.03 times 0.02 divided by 0.3 plus 0.02. So we can have the combination of the two, which is equal to 0.012. Okay? So to find the generated EMF, apply the formula. So AG is equal to VL plus, okay, so we have voltage drop across the, here. Then IA, RA plus the combination of the two. So 220 given, 220 volts plus, okay, since 1.5 per brush, so times 2, so 2 times the 1.5 plus IA is equal to 102 times the RA, which is equal to 0.01 plus 0.012. All in all, we have the generated EMF of 225.24 volts. Okay, so try to solve what is the generated power generated in the armature, as well as what will be the current across the diverter resistance, and also what will be the generator's efficiency given this situation. So what else? Daghan pa kitang pwede masolve. Okay, so it's that's all for this video, so I'll be posting a video for more examples. Okay, so thank you and God bless everyone.